In this video today, I'm going to demonstrate the modeling of the multiplication of decimal numbers. I'm going to use a 100s grid in order to demonstrate how this can be done. So let's first take the problem 5/10 multiplied by 3/10. I'm going to use a different color to represent each one of these decimal numbers. So first, I'm going to use green to represent 5/10. So up at the top, I'm going to write 5/10, and I'm going to mark off in the columns 5/10 of the whole entire grid. Well, each one of these squares represents 1/100th of the whole entire grid. So in order to get 5/10, I would have to mark off, first of all, one column, and I'm going to mark them in this way in diagonals going in just one direction. And you'll understand in just a moment why I'm not going to color in the whole entire block. So right now I have 10/100ths, which is the same as 1/10. So there's 1/10 marked off. Now I'm going to continue. So this would be 2/10 of the grid marked off. This is now 3/10 marked off. 4/10 marked off. And finally, 5/10 marked off. So once again, just to be clear, one entire column makes 1/10 of the whole entire grid. Now, I'm going to use red to represent 3/10. And so that we can see it very distinctly, I'm going to put 3/10 over to the left. And this time I'm going to mark off the rows that would create 3/10. But this time the diagonals are going to go in the opposite direction. So this would be 1/10 of the entire grid, 2/10, and 3/10 of the grid. In order to find the answer, and I'm going to highlight it to make it a little bit easier to see, the answer is where the two lines cross each other and form an X, which is here in the highlighted section. So if we count these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 individual blocks. So that's 15 out of the whole 100 blocks. So that means that 5/10 multiplied by 3/10 is 15/100ths. Now let's look at that in a traditional algorithm. If I multiply, and I'm just going to drop the whole number zeros for right now because the zeros just show there's no whole number. 5/10 multiplied by 3/10. Now there are several ways to talk through this, and I'm just going to do it in the shortest, most efficient way. 5 times 3 is 15. You would multiply those together as if those were whole numbers. One way to figure out the placement of the decimal is to look in the entire problem and count how many digits are behind a decimal in the problem. Well, there's 1, 2. So that means in the answer, we have to put the decimal to where there are 2 digits to the right or behind it, which would have to go in this location. So once again, it does match. We have 15/100ths. So this is one way that you can model the multiplication of decimal numbers. Now, let's take a different problem. Let's do 7/10 multiplied by 9/10. So this time I'm going to use the same color, 7/10 multiplied by 9/10. And this time I'm just going to shade in where 7/10 and 9/10 sort of create their own rectangle. In other words, over here to the side, for 9/10, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths would go here. Now, to get 7/10 up at the top, I would count over 7, 1, 2, 3, 4, 5, 6, 7. And now I'm just going to kind of finish off the rectangle in this fashion. Next, I'm going to just shade in this entire area in pink. I'm not going to do anything about marking them out. Give me just a minute to shade all of this in. It's okay if I leave a couple of little white spots in it. But I want to get most of it shaded in so you can tell what is shaded. Now, all that's left to do is count how many individual blocks we have. So that I don't lose count, I'm just going to put a small dot in each one. Now remember, these each represent 1/100th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. So that would be 63 out of 100 blocks, which would be 63/100ths. So my answer to 7/10 multiplied by 9/10 would be 63/100ths. So let's look at that in the standard algorithm. 7 times 9 is 63, as if the decimals weren't there. Then count the total number of digits behind the decimal in the problem. There are 2, so there have to be 2 digits behind or to the right of the decimal in the answer, 1, 2, which there are, 63/100ths. So this is another way that you could represent 7/10 multiplied by 9/10. Now let's look at one more example. This time we're going to multiply a decimal number by a whole number. Let's take 36/100ths multiplied by 4. Now, one way to think of this, which I think makes a little more sense, is to use the commutative property and switch these two around. So let's think of it as 4 times 36/100ths. The reason I'm going to switch it around using the commutative property is because it makes a little bit better sense when you see it in the model when you think of it this way. We need 4 groups of 36/100ths. So 4 groups of 36/100ths. So to do this, I'm going to use different colors and actually shade in 4 different groups of 36/100ths. So I need to get my first 36/100ths. So I know this is 30, and then I need 6 more. 1, 2, 3, 4, 5, 6. So there's my first group of 36/100ths. Now for my second group of 36/100ths. So I have 4 here. Okay, 4. 14. 24. 34. 36. There's my second group of 3600s. Now I need a third group of 3600s. So I have 8. This would make 18. This would make 28. But now I've run out. So 28, and I need to go to the next grid of 100. 28, 29, 30, 31, 32, 33, 34, 35, 36. There's my third group of 3600s. And finally, I need a fourth group of 3600s. So there's 2, 12, 26, and 36. So 3600s. Now I have my 4 groups of 3600s. So once again, here's my first group, here's my second group, here's my third group here, and here is my fourth group. Now all I have to do is count up the total amount of both blocks that are shaded in. So I'm going to clean this up just a little bit. Okay, now I can just see the blocks. There we go, all by themselves. So this entire grid is shaded in. That's one whole grid, and on the second grid, I have 10, 20, 30, 40 hundredths shaded in. So that means that 4 times 36 hundredths would equal 1 and 40 hundredths. Now let's look at this in the algorithm and see if that's correct. Sorry, but my pen is connecting again. It tends to do that on this computer. Excuse me. Now, using the traditional algorithm, I'm going to put the number with the most digits on top. So 36 hundredths has the most digits. I'm going to multiply that by 4. So notice I just switched right back around using the commutative property back to the original problem. Now, let's multiply as usual. 4 times 6 is 24. Put down the 4, carry the 2. 4 times 3 is 12, plus 2 is 14. Put down the 4, carry the 1. 4 times 0 is 0, plus 1 is 1. Move the decimal. In the whole entire problem, there are 2 digits behind the decimal. So in the answer, there have to be 2 digits behind the decimal. So 1 and 44 hundredths. Oh, well now, wait a minute. Those did not match. I must have made a mistake somewhere. So the best thing to do is just to go back, and instead of redoing the whole thing over again, I probably have made a careless mistake in the counting of my groups of 36. So I'm just going to go back and make sure I've counted my groups of 36 correctly. Okay, so I have 10, 20, 30, 1, 2, 3, 4, 5, 6. I'm okay in the purple section, or the pink section, whatever it looks like to you. Okay, now I've got to make sure I have 36 in the blue section. So I'm going to count them kind of like I did the pink or purple. 10, 20, 30, 4, 5, 6. Okay, there's 36 there. I'm okay. So now I have 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I'm okay there. And in the last section, I need to make sure I have 36. Oh, look, I think I already see where I've made a mistake. I have 10, 20, 32. I did not shade in enough of them. 32, so I have 32, 33, 34, 35, 36. I accidentally left 4 of them off. See, just by simply counting, I did not have to go back and start all over. So I'm glad this happened to show you that sometimes your careless mistakes, you can fix them if you just go back and count carefully. So now all together in this grid, I have, let me clean that up just a little bit. I have all together, there's 10, 20, 30, 40, and the 4 that I just colored in that kind of disappeared. Sorry about that, but remember they were there just a minute ago. I backed it out too far. So that actually is 1 and 44/100ths. So this is one way that you can demonstrate modeling of multiplying a whole number by a decimal number. Think of them as how many groups of the decimal number do you need to show. Okay, since my pen kind of messed up on that one a little bit, let's look at one more. Let's say you've got 14/100ths multiplied by 5. So once again, I'm going to use my commutative property and think of that as 5 groups of 1400. Now this time I'm going to make sure to take a little bit more time on my shading and count just a little bit more carefully. Okay, so I need one group of 1400. So there's 10, 11, 12, 13, 14. There's one group. So now two groups. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's two groups. Now three groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Four groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I need one more group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, this time I didn't even use this other box. Or grid, I mean. So let's look and count the total number that are colored in. So I have 10, 20, 30, 40, 50, 60, 70 hundredths. So 70 hundredths, or if I counted them as tenths, it would be 7 tenths. So let's look at that using the traditional algorithm and see if we get the correct answer. 14 hundredths multiplied by 5. Once again, putting the 14 hundredths as the multiplicand because it has the most digits. So using our algorithm, 5 times 4 is 20, put down the 0, carry the 2. 5 times 1 is 5, plus 2 is 7, and 5 times 0 is 0. In the entire problem, there are 2 digits behind the decimal or to the right of a decimal. So in the answer, I have to place my decimal where there are 2 digits behind it. So I get 70 hundredths, which is the correct answer.